Hey everyone, and in this video, this is what we are going to achieve. So in the previous videos, we've been working with a pretty basic Python script, but in this case, we're going to flesh that out and have a realistic looking trace come out of the end of it. It is a multi-step trace, and we do it for a couple of reasons. The first is that it's more realistic. The second is to demonstrate how quickly your JSON payloads and spans and traces can quickly take up your space. And the third is to demonstrate how context works in OpenTelemetry and how the traces and span IDs get passed around automatically a lot of the times for you. So let's jump straight into the code. The very first thing you're going to need, of course, like all the other tutorials, is a place to send the spans. I'm going to use Jaeger. So I'm going to start my Jaeger instance now. I've had it running before, hence the weird Musing Galileo container name. And let's just check that's running. Yep, it looks good. Let's make sure it's running and available in the browser. On localhost 16686. Perfect. Jaeger is up and running. Second thing we need is a collector. So remember, our application is going to send spans to the collector, and the collector will forward those to Jaeger. So let's start the collector now. And for ease, I've just got the collector binary in the local directory, but you can, of course, add it to your path. Now it's time to start building out the application. So the first thing we're going to do is create a requirements.txt file as standard. Let me just copy this in here and explain it. So we have OpenTelemetry API, OpenTelemetry SDK, and then OpenTelemetry Exporter, OTLP, Proto-gRPC. API and SDK are the bits of the code that you need, think of it that way, and the export is how the spans are going to get out of your Python code and into the collector. So in this case, we're saying use the OpenTelemetry protocol in protobuf format and use gRPC. There are libraries for HTTP, but I'm going to use gRPC. The next thing we need, of course, is the application code. So it's a little bit longer, a little bit complex. I'm just going to copy and paste it in, and then we'll walk through it together. So head on over to the GitHub repository that I put in the video description below. Head to the part 4 folder, and then app.py, and just copy all of this code. Head back in here, create a file called app.py, and paste in the code. The program I've created here implements the logic of a kids game. Basically, it takes some input and provides by magic, the birthday and the birth month. The point here is that the program is doing multiple things, multiple steps that we want to track as a complex trace to model a real-world application. The reason I'm telling you this is because you can't just run Python app.py. You need to give it some parameters, namely the birth day and the birth month. So let's run that now. Let's jump into Jaeger and see what we see in terms of the spans. Let's refresh Jaeger, and we should see two services. And of course, remember, we're looking for Adam's MacBook Air, not Jaeger all-in-one. That's Jaeger tracing itself. So let's hit find traces, and we should see a trace here called do calculations. Now let's have a look at this, and let's investigate. It looks good. I mean, it took 255 milliseconds, and we've got multiple steps in here. If I click in here, I can see the tag on the top level of do calculations has a result, 27.10. Perfect. Clicking down into each of these subtasks, or child spans, multiply, has a tag called first, a value of 7, a key of second with a value of 27, and a result. And remember the previous videos, this is just giving your human operators some extra context because they're not going to be able to look at the code probably. So you want to give them as much context as possible. So now that we like the look of this in Jaeger, let's have a look and see how this is actually happening. Let's start down here where the program actually starts. And the first thing we do is we start a span called do calculations. You can think of this as the parent span. This is kind of the clock starting at the start of the day, and then anything that happens inside that gets tagged as a child span inside. So we set the result as 7, and then we multiply by the birthday, we subtract, we multiply, and so on and so forth until we finish. Jumping into each function, we can actually see that they have been decorated. So each function, as in multiply here, starts a span for itself, for the multiply function. But of course, there is a parent span, the do calculations. So that's how you're seeing that kind of nested view of the world, because do calculations in effect is still running. Multiply runs and it finishes, and then the code goes to subtract, and the same deal. We start a subspan, and then that finishes. Do calculations is still running, and so on and so forth. So that's how you get this sort of childlike relationship between the spans, and that's how you get this view. Flick across back into the repository and go back to the folder and copy and paste the code from app.py. Create a new file called app.py. Paste that in, and let's run the code again, but this time use app.py. Let's flick back into Jaeger and see what that looks like. So again, hit find traces, and we now see there's another trace do calculations, but this time it's got 36 spans. So let's have a look and see whether we can guess, just by looking at Jaeger, what's going on here. Well, we've still got the do calculations. We've still got multiply, subtract, multiply, add. So if I collapse these, we've still got the high level. It looks exactly the same. However, there's even more children underneath each of the add nodes. So you can see you can drop down each of the adds, and it's got this weird add loop 1, 2, 3, 4, and so on, only for each of the add nodes. As an operator, I need to figure out what's going on. So let's see what we can see. So we've got our first number again, and our second, 10. That looks interesting because the number 10 just so happens to be the exact number of loops that we have. I'll keep that in mind. Let's see if that holds for the other add methods. Add, first is whatever it is, second is 3. Okay, I'm starting to understand. There's some logic going on in the code. What about this one down here? No, that all looks pretty standard. Apart from this one, add loop 6. It's got a loop number 6, and it says special number. Yes. Okay, so as an operator, I've got a lot more context now to send back to my developers to say, you know, folks, there's something odd going on here because you've introduced something new in the code where we're stuck. It looks like we're stuck in a loop, and the number 6, something else is happening weird there. That is fantastic context for a developer to have a look at the code. So let's have a look at the code and see what's going on. In app2.py, everything looks the same. I particularly want to have a look at the add method because that looks odd. Okay, so here we go. Count is 1, and while the count is less than or equal to the second value, we are in a loop. Okay, that makes sense. And then inside that loop, we start another child span. So this is the cause of why our trace suddenly blew out in complexity. And there's an if statement here. If the count is 6, set a special number to yes and the loop number to the count. So that's how those attributes got in there. Now, of course, this is a contrived example, but it demonstrates a real-world problem, and that's the N+1 query problem. So sometimes developers will call a database multiple times. For example, they won't get users in batches. They'll get user number 1, user number 2, user number 3, and every time they retrieve a user or a record, they'll go back to the database. And that's precisely what you will see in your traces. You'll see this sort of endless loop trace behavior in your traces. So that's just something to watch out for, especially if you look like you're doing the same operation over and over and over again. That's an optimization that you might be able to take back to the developers. So in summary, in the past 4 videos, we've really dug into Python. We've dug into manually tracing your code. I hope I've shown that it's really not that scary and complicated. And in the next video, we're actually going to cover something that was requested in the comments. And this is fantastic. If you have ideas, suggestions of what you want to see, I want to create that content for you. So in the next video, we're going to cover sampling. So join me then. Until then, thanks for watching. See you soon. Bye.